Hi, today we will be doing line symmetry and rotational symmetry. Line symmetry is a line across which a figure maps itself by a reflection. Example 1. Find all the lines and their equations across which the figures below map onto themselves. Well, the first figure we have is a rectangle. And the rectangle reflects itself horizontally through this line right here, which is the line y equals 2, and vertically through the line x equals 1. Next we have a trapezoid. Now a trapezoid is a little bit different than a rectangle. A trapezoid can only reflect itself one way, which is through the horizontal line of y equals -2. So now we have three shapes, and we need to draw all the lines across which the figures below map onto themselves. First we have a square, and we want to draw the lines on which a square maps itself onto itself. Of course we have the obvious ones, which are the horizontal and vertical ones. But with it being a square, you also have the two diagonals. So that gives you 4 lines of symmetry. The next shape we have is a pentagon. And a pentagon is not that obvious. You do have the one line of symmetry which starts at the top vertex and goes through the midpoint of the opposite side. But you need to do that at every vertex. So you start at F and do that, then move to E and also do that, and then move to I and also do that, and then move to H and also do that. That gives the pentagon 5 lines of symmetry. And last, we have a hexagon. And our hexagon has the obvious horizontal and vertical. But now, if you also look at it, we went from C to F, we can go from B to E, we can also go from A to D, and then we cut the middles of these two sides, so let's cut the middles of these two sides, and the middles of these two sides, so that gives us 6 lines of symmetry. Along with lines of symmetry, you also have rotational symmetry. Rotational symmetry is when a figure rotates about a point so that it maps onto itself. Example 3, locate the points around which each figure is rotated onto itself and give the number of degrees of rotation. Now if you remember, this is the rectangle we just talked about. We had the lines of symmetry that went here and went here. If you notice, they meet at a point. This point is our center of rotation. That point is the point 1, 2. Now with it being a rectangle, can we rotate it a certain number of degrees? We can only rotate it 180 degrees. Otherwise, we'd have to rotate 360 to get back around, and that would just take it back to itself. Now, same thing with this one. There's our line of symmetry. The center of this point in the middle would be at 2, -2. But there's no way except to rotate it all the way around 360 that would give us a measure of rotation. So 180 and none. You do not say 360 because that is a complete circle. And that's an obvious rotation. Every figure can be rotated 360 degrees to map onto itself. Find the number of rotational degrees of symmetry that each figure has below. Give the degrees of rotation for each symmetry. Each figure is rotated about the origin. Okay, find the number of rotational symmetries that each figure has below. So, here's the degree of rotation. So how many times do you think we can rotate this? Well, it looks like it has 3 vertices. I think we could probably rotate this 3 times. And we can probably rotate it 120 degrees, 240 degrees, and we can always rotate it, like we said, 360 degrees. Now if we move to the next one, here's our center of rotation. It's a square. 4 times, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And last but not least, we have a pentagon. 5 times, because we had 5 lines of symmetry. This one had 4 lines of symmetry. This one had 3 lines of symmetry. (72 degrees, 144 degrees, 216 degrees, 288 degrees, and 360 degrees. A regular polygon rotational symmetry regular polygons are polygons that have all equal sides and angles. Regular polygons have one less rotational symmetry than the number of sides. Divide 360 by the number of sides. Formula is 360 divided by n. Every multiple of this value is a rotational symmetry for a polygon. So, list all the rotations for the polygon below. A hexagon. A hexagon has 6 sides. So 360 divided by 6 is 60. And then we multiply by 2, we get 120. Add 60 to that, we get 180. Add 60 to that, we get 240. Add 60 to that, we get 300. A heptagon has 7 sides. We get approximately 51.4. Multiply that by 2, 102.8. Add 51.4 to that, we get 154.2. Add 54.1 to that, we get 205.6. Add 51.4 to that, we get 257. Add 51.4 to that, we get 308.4. Which we rounded there, so we're not going to come exactly to 306 because we rounded. And last but not least, the octagon. 360 divided by 8 is 45. Times 2 is 90. Plus 45 is 135. Plus 45 is 180. Plus 45 is 225. Plus 45 is 270. Plus 45 is 315. And our last and final examples for the day. Describe all the possible symmetries that could map each figure onto itself. Well, this is a 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6-sided figure. So it's a hexagon. So we could do rotation about 0, 1 of 60 degrees, 120 degrees, 180 degrees, 240 degrees, or 300 degrees. Any of those angles. The last one is a star. A star is also a pentagon. It has 5 sides. Rotation about the origin of 72 degrees, 144 degrees, 216 degrees, or 288 degrees. Thank you, and I hope you enjoyed your lesson today about symmetry.